We recommend that you watch this video from start to finish at least once before you begin the assembly process. To keep your shipping cost at a minimum and protect the machine, your system is shipped in several boxes, UPS. The labels indicate the components contained in each box. Check off each item in your manual as you remove it from the box. The box label should then match your manual when completed. If you are missing any components, contact Phantom immediately. Throughout the assembly process, you will find the hardware and components required for each step carefully labeled. Begin with the floor stand hardware. Start by placing a floor stand bracket and gusset on a flat surface. Place a floor stand leg between the two and insert two 1/4 by 2 3/4 inch bolts with flat washers. Then secure these with flat washers and nylock nuts from the other side. Leave the bolts just loose enough to allow a little play at this time. Lay the floor stand rails on their sides and insert the 1/4 bolts with flat washers into the rails from the side that has the pair of tapped mounting holes. Stand the rails up on the bolt heads and place the leg assembly onto the bolts and secure them in place with flat washers and nylock nuts. Place the floor stand right side up on the floor and tighten the top rail bolts first, followed by the bolts that hold the legs. Slide the tailstock onto the tailstock support assembly. Fasten it securely in place with 1032 cap screws and flat washers. Next, insert the 4 glide bushings into the tailstocks. Turn the clamping knobs in a couple of turns. Now remove the backing from the tape on the brake pads and stick them to the threaded inserts inside the assembly. The tape will hold the brake pads in place until you insert the bed rails. Remove the linear drive screw that is shipped inside one of the bed rails. You can easily identify the bed rails because they have no holes in them. Insert the bed rails into the tailstock support assembly. Slide them into the middle and secure in place by tightening the clamping knobs. The headstock support assembly has two threaded holes next to the brass bushings. Slide the headstock onto its support assembly from the opposite side of these threaded holes. Fasten it securely in place with 1032 cap screws and flat washers. Turn the clamping knobs in a couple of turns. And again, remove the backing from the tape on the brake pads and stick them to the threaded inserts inside the assembly. Now insert the support shafts. Slide them into the middle and secure in place with the clamping knobs. Now repeat the same process for the end support assembly. Insert the bed rails into the headstock support assembly. The rail should extend through the holes approximately 1/16 of an inch. Be sure that the Morris taper pilot hole is facing the tailstock. Insert two 1032 by 3/4 inch cap screws into the base of the headstock support assembly to secure the bed rails at this end. Tighten the screws just 1/2 turn after they contact the bed rails. Over-tightening will bind the support shafts. Loosen the clamping knobs and set the bed rails to the middle of the support shafts on both ends of the machine. Secure the four 2-inch support shaft mounting brackets onto the top of the floor stand rails using 1032 by 1/2 inch cap screws and flat washers. Do not tighten these screws at this time. Set the machine onto the floor stand. Set the support shafts into the mounting brackets and insert the 1/4 by 2-inch cap screws. Thread the 1/4 nylock nuts onto the screws until the end of the screws extends approximately 1/8 of an inch beyond the nut. Now suspend the elevation support bar between the cap screws. and then tighten the nylock nuts on both sides. Place a 1/4-inch flat washer onto the screw and thread on a nylock nut. Do not fully tighten this nut. You will want to leave a 1/16-inch gap for alignment of the elevation screw. Thread on a nylock nut onto the opposite side, again leaving a small gap. If you tighten these nuts too tight, you will bind the support shafts. Now thread in the elevation screw from the top side of the support bar and insert the brass washer on the end of the screw into the hole at the base of the support assembly. Insert and tighten the 4 1032 by 1/2 inch cap screws to pull the brass washer into the hole. Now place the handle onto the end of the elevation screw and tighten the set screw. Loosen the clamping knobs and turn the handle to raise or lower the bed, and then tighten the knobs to lock it in place. Mount the 4 3.5-inch support shaft mounting brackets to each end of the top rails with 1032 by 1/2 inch cap screws and flat washers. Be sure that the threaded inserts are on the same side on each rail, and once again, do not tighten these screws at this time. Place the top rails onto the support shafts. Be sure that the threaded inserts are to the outside of the machine. Now insert the 4 1/4-20 by 1.5 inch cap screws. Thread on the 1/4-20 nylock nuts and tighten securely. Loosen the cap screw on the mounting bracket of the spiral drive reverse assembly. Swing it to the open position and then lock it in place. Now mount the drive reversing assembly with 2 1032 by 1/2 inch cap screws and flat washers. Tighten these screws securely. The linear drive screw has a short and a long machine end. Grease the long end of the screw and place a thrust washer on the end. Insert the drive screw into the bushing in the motor mounting bracket. Grease the screw and the inside of the bushing and place a brass washer onto the end of the screw. Slide the coupler shaft onto the end of the screw and tighten the set screw. Be sure the set screw goes onto the flat surface that is machined on the linear drive screw. Now rotate the bracket to ensure that it turns freely. Mount the motor to the bracket using 1032 by 1/2 inch cap screws and tighten the set screw on the flat of the motor shaft. If you purchased the larger motor, mount it with the hardware that was supplied. Mount the linear drive screw and the motor assembly to the system. Insert the short end of the screw into the drive shaft at the headstock end and tighten the set screw onto the flat surface. Mount the motor bracket using two 1032 by 1/2 inch cap screws and flat washers. Leave these screws loose enough to slide the bracket forward and backward at this time. Lock the index pin back with the retainer clip. Remove the 45-tooth spur gear from the drive shaft. Apply a little grease to the spindle shaft and the drive shaft. Now slide the interlocking pivot arm onto the shafts. Be sure the axle in the center of the arm points away from the headstock. Then replace the spur gear. There are 4 gear reduction sets and 5 drive gears available for your system, allowing a total of 20 pitches. For setup and alignment purposes, we will use the 2 flange washers, the 60-tooth drive gear, and the 0.25 times gear reduction system. Be sure that the interlocking pivot arm is fully extended. Then mount the index gear onto the spindle shaft using a clamping knob, a lock washer, and a flat washer. Apply a little grease and then slide the gear set onto the axle and engage the gears. Lock them in place with the cap screw on top the pivot arm. Next, place one of the flange washers onto the drive shaft, followed by the 60-tooth drive gear, the second flange washer, and the handle. Secure these in place with a 1032 by 1/2 inch cap screw and flat washer. Stand the carrier tray on its edge and remove the Y-axis positioning bracket from the router base. Check to see that the fence moves freely and position the base at one end. With the fence resting on the router base, tighten the nylock nut to hold the fence in place. Use the T-handle Allen wrench to hold the cap screw from the underside. Now slide the base to the opposite end and tighten the second nylock nut. Place the router carrier tray on the top rails with the Y-axis positioning screw on the same side as the headstock. Now use the T-handle Allen wrench to set the travel tension by tightening the cap screws until the tray stops moving. Then back the cap screw off approximately a 1/16 of a turn. Repeat this step for the second cap screw. Mount the coupling shaft to the Y-axis positioning screw and secure it with the set screw. Now slide on the handle and tighten the set screw to lock it in place. Loosen the captive locking screw in the split nut. Open the nut and slide it up under the linear drive screw and secure it to the carrier tray with a 1032 by 1/2 inch cap screw. You will need to align the linear drive screws so that the gears align properly. Slide the linear drive screw forward or backward until the gears properly align. Now tighten the cap screws in the motor mounting bracket. To set the proper spacing between the top rail and the linear drive screw, slide the router carrier tray to within a couple of inches from the end of the screw and close the split nut. Now tighten the cap screws that secure the support shaft mounting brackets to the bottom of the top rails. Repeat the same process at the headstock end as well. Now tighten all of the cap screws that secure the machine to the floor stand and the opposite top rail. Hang the junction box in the middle of the floor stand rail. The control box can be placed anywhere that is convenient. Plug in the linear drive motor. If the switch on top of the junction box is pointed toward the headstock, the box will control the optional spindle drive motor. To control the linear drive motor, flip the switch toward the end support. The side opposite the linear drive screw is referred to as the back. Mount the two micro switches to the back top rail at any desired start and stop location. The control box can be operated from any position around the machine. Use the speed control and direction switch to start the motor. When it reaches one of the micro switches, it will automatically stop. You can then reverse the direction and push the momentary override button to start the motor driving in the opposite direction. The speed control can also be used to start and stop the motor manually. Both the tailstock and the headstock have a number 2 Morris taper pilot hull. You can insert any type of center that you desire. We recommend that you use the index drive center on the headstock. Slide it onto the spindle shaft and secure the cap screw onto the flat that is machined onto the spindle shaft. There are 2 different router bases available for your machine. The standard base, which comes with every system, and the base for the optional Y-axis template follower. Mount the second one if you purchased this accessory. Start by peeling off the protective covering from the base. Next, place the base onto the router carrier tray with the two studs on the same side as the positioning screw. Place the router onto the base and center it. Note that the original base has been removed from your router. You will probably need to turn your router as shown to keep the handles from interfering with the positioning screw bracket. Flip the bracket over and back to make sure that you have adequate clearance. Then scribe a line around the router and mark both the router and the base to reference the proper alignment. Set the router upside down and set the base on top of it. Position the base using the lines scribed for alignment. Now carefully mark the holes for mounting the base. Drill and countersink the holes as shown on this Y-axis router base. Attach the base with the original screws from the router. The holes must be countersunk deep enough that the heads of the screws are below the surface of the base. Set the router onto the carrier tray and attach the positioning bracket with the two flat washers and 1032 wing nuts. This completes the assembly process for the professional package. The following are additional accessories that you can purchase at any time. Mount the spacing block and angle with the hardware provided. Note that there are two sets of holes to adjust the height of the brackets for different thicknesses of baseboards and templates. These must be mounted on each end of the top rail. Cut a baseboard the length of your system and about 3 inches wide. Then slide the carrier tray to the end and push the baseboard back against the tray to mark the slot from underneath. Mark and drill a 1/2 inch hole in the end of the slot and then countersink the top side. Mount the baseboard with the 1/2" flathead screws and wing nuts on both ends of the machine. Any template that you design can now be mounted anywhere along the baseboard. The roller on the base will now follow the template, moving the router from side to side as it moves from end to end. Put a little grease on the face of the mounting bracket and plate. Place 2 brass washers over the center hole and attach the plate to the bracket with the shoulder bolt provided. Tighten this securely, but check to see that the plate will rotate on the bracket. Mount the motor on top of the plate with 4 1032 by 1/2" cap screws. Slide the gear assembly onto the motor shaft and tighten the set screw onto the flat of the shaft. Screw in the clamping knob through the slot on the plate and into the bracket. To set up the spindle drive motor, you will need to remove the gear set from the interlocking pivot arm. Next, remove the 4 cap screws from the outside face of the headstock. Mount the spindle drive motor with the cap screws and flat washers provided. To align and use the spindle drive motor, you will need to attach the 180-tooth index gear from the standard gear reduction system to the headstock. Align the gears and tighten the set screw in the gear assembly. Now plug the wire into the junction box. And into the spindle motor. The switch on the junction box must be pointed toward the headstock to control the spindle drive motor. If you are using the base for the Y-axis template follower, you will need to remove the roller to use the rotating router carrier tray. Set the carrier tray on the top rails and set the router in place. Adjust the fence for the base, making sure that the router slides freely without any slop side to side. Tighten the travel tension screws until the carrier tray stops moving, and then back off the screws approximately a 1/16 of a turn. Now transfer the split nut from the standard carrier tray to the rotating tray. And remove the standard carrier tray. Mount the coupler shaft and the handle to the Y-axis positioning screw. The tray has a cap screw that locks it at 0, 22.5, or 45 degrees in either direction. You can also lock it at any angle with the wing nuts located on each side under the tray. The center stock stabilizer will allow you to support round stock while you mill spirals. Start by removing the base to mount it to the system. Now set it on the bed rails between the headstock and the tailstock. Replace the base and secure it with the wing nuts. The rollers automatically spread out for larger diameter stock and move close together as they are raised for small diameter stock. To mount the eliminator chuck, simply remove the collet nut and replace it with the chuck. Tighten it securely with the standard wrenches. Insert the desired bit and lock it in place with an Allen wrench. The bits will release instantly and lock in securely with just a quarter turn of the wrench. The optional dust collection system quickly attaches to the carrier tray to contain and remove the sawdust using a shop-vac or commercial dust collection system. It can be mounted facing either the front or the back of the machine. Simply drop it down over the stock and slide the carrier tray over the top. Then lift it into place and tighten the cap screws on both ends. The cap screws should be snug, but do not over-tighten them. The brush system allows you to slide the carrier tray past the tailstock to remove or insert the stock. Or you can slide the stock up through the brushes from the bottom side. The last step is simply insert the hose and you're ready to run. The brushes will mold around the stock and contain the dust, which will save you a lot of time cleaning up. In just a few minutes we will build these two sample parts that show all of the basic operations and techniques used for creating thousands of different styles and projects. All you need to do is practice these techniques and then start challenging your imagination. Before we begin making sawdust, we'll quickly demonstrate the 5 basic operations. Although the operations are simple to understand and use, they make the woodchuck an extremely versatile milling system. The XY milling table allows you to mill along the length or perpendicular to the workpiece. Each axis has a 4 threads per inch positioning screw for precision control. You can also disconnect the drive screws and move the router manually in both directions. The Z-axis is set by your plunge router. The rotational axis can be controlled manually with a hand crank or driven by a variable speed motor as shown here. This allows you to mill your stock round or to mill beads and coves and other decorative cuts around the circumference of the workpiece. The system comes with a 40 and a 36 position indexing plate. The gear reduction systems also have indexing holes for milling multiple start spirals and performing other indexing operations. This indexing feature allows you to mill multi-sided cross-sections, flutes, reeds, or other decorative cuts, as well as precision joinery such as mortises and slotted dovetails, even on round stock. You can easily change to any one of the indexing plates or indexing gears by simply removing the clamping knob. The index pin has a retaining clip to hold the pin back when turning the stock. Releasing this clip will allow the spring-loaded pin to engage firmly into the hole. The adjustable bed allows you to mill stock up to 12 inches in diameter. Raising both ends will bring a small diameter stock up close to the router. Adjusting either end allows you to mill tapers in both directions. And lowering both ends will allow you to mill the large diameter stock. The elevation screws raise or lower the bed 1/4 of an inch for each full rotation. The spiraling system has drive gears for 5 different pitches. Every system has the standard gear reduction set. By changing the gear reduction set, you will have another range of 5 pitches. There are 4 of these gear reduction sets available, giving a total of 20 pitches. In the first column you see the 5 drive gears. The second column shows the pitches for the standard gear reduction set, 3, 4, 5, 6, and 7.5 inches per rotation. Column 3 shows that if you change to the 2 times gear multiplier, you will double the standard pitches. Column 4 shows that the 0.5 gear reduction set cuts the standard pitches in half, and column 5 shows that the 0.25 reduces the standard pitches to 1/4. Place the index gear onto the spindle shaft and secure it in place with the clamping knob. Place the gear set onto the pivot arm axle with the small gear to the inside. Now engage the gears and lock them in place. Place one of the large flange washers onto the drive shaft, followed by the drive gear, the second flange washer, and the handle. And secure them in place. Now engage the drive gear and lock it in place. The system can now be operated manually or with the linear drive motor to mill right-hand spirals. To mill a left-hand spiral, you need to place the drive gear onto the reversing shaft. Start by disengaging the drive gear and remove the handle, drive gear, and flange washers from the drive shaft. Engage the reversing drive gear and lock it in place. Now remove the spacer from the reversing shaft and place it onto the drive shaft. Then place the flange washers, drive gear, and the handle back onto the reversing shaft. Loosen the cap screw in the curved slot and position the reversing shaft directly below the drive shaft. Now engage the drive gear and the system will mill left-hand spirals. The XY milling table, rotational axis, indexing head, adjustable bed, and spiral drive system are all very easy to understand and use, but the possibilities are only limited by your imagination. To start making sawdust, get yourself 2 pieces of wood approximately 2 by 2 by 26 inches long. You can glue up several pieces or purchase solid stock as shown here. Be sure that the ends are cut square. Now find the center of each end by drawing a line from corner to corner. Even if the stock isn't perfectly square, this technique will still find the center. Place an indexing hub over the center of the stock and mark the screw holes. If possible, cut off the corners of one of the pieces on your table saw or joiner. This step will save a lot of wear and tear on your router bits when milling the stock to a round. Drill the pilot holes and mount an index hub on one end with drywall screws. Now drill a hole in the opposite end for the live center. These 2 pieces are now ready to be put into the woodchuck. Insert the piece with the corners removed into the indexing drive center. Position the quick release handle at just less than a 45-degree angle. Slide the tailstock into position and lock it in place with the clamping knobs. Now press down the quick release handle to load the system. Setting the handle higher than 45 degrees will put too much load on the headstock and tailstock. Place a straight edge across the top rails and raise the adjustable bed until the top of the headstock is even with the top rails, then lock in place with the clamping knobs. Now repeat this operation for the tailstock end as well. You can also set the bed without a straight edge by sighting across the top rails. Raise the bed until the top of the chassis, not the lid, is even with the rails. The workpiece should now be level or parallel to the top rails. Start with a surface planing or bottom cleaning router bit. The cutting diameter of this bit should be 1 1/4 or 1 1/2 inches. Offset the router 7/16 of an inch for the 1 1/4 diameter bit, or 9/16 of an inch for the 1 1/2 diameter bit to the side opposite the linear drive screw, and then lock it in place with the router stops. To mill the stock round, we'll use the gears for the 3/4 inch pitch. Referring to the gear chart, we'll use the .25 gear reduction set and the 60-tooth drive gear. Start by placing the .25 gear reduction index gear onto the spindle shaft. Next, place the gear set onto the pivot arm and engage these gears. And finally, place the 60-tooth drive gear onto the drive shaft and replace the flange washer and handle. Note that if your system is motorized, you may replace the handle with a second drive gear to act as a spacer so that the handle does not get in your way. Now engage these gears. Rotate the workpiece until one of the flat surfaces is on the top side. Plunge the router bit down until the bit rests on the surface of the workpiece. Now set the plunge to mill approximately 1/16 of an inch. Position the microswitch stops at the end of the top rail to keep the router bit from hitting the index hubs and index drive. Slide the carrier tray to the tailstock end and close the split nut. Position the toggle switch on the junction box to the left to control the linear drive motor. Start the router and plunge down to the preset depth. Then turn on the linear drive motor to cut from the tailstock to the headstock. If the feed rate is too fast, the stock will start to chatter. If you feed it too slowly, it will burn. When the carrier tray reaches the microswitch at the headstock end, the linear drive motor will automatically stop. To mill the rope section, we use Magnate's 1 1/2 inch diameter rope molding bit. Again, referring to the gear chart, to mill a 3-inch pitch, we'll use the standard gear reduction set and the 60-tooth drive gear. Since the 60-tooth drive gear was just used to mill the 3/4 inch pitch, we only need to replace the .25 gear reduction set with the standard gear reduction set to get our 3-inch pitch. Now make a mark 3 1/2 inches from the headstock end of the workpiece and 6 inches from the tailstock end. Move the carrier tray until the center of the router bit lines up with the first mark. Now slide the microswitch up against the carrier tray. Then repeat this step at the tailstock end. Position the router directly over the center of the workpiece and tighten the router stops to lock the router in place. Now plunge the bit down until it rests on the workpiece. Then set the plunge stop for just less than 1/4 of an inch. Turn on the router and slowly plunge the bit down into the workpiece, and then start the linear drive motor. You will need to adjust the cutting speed for different size router bits and different types of wood. When the carrier reaches the microswitch stop, the linear drive motor will stop. Lift the router bit out of the workpiece, open the split nut, and slide the carrier tray back to the tailstock end. With the router turned off, plunge the bit back down into the workpiece and slide the carrier tray until the bit lines up with the cut you just made. When the bit is properly aligned, the split nut will close. Lift the bit off of the workpiece and drive the carrier tray back to the micro switch. Now lift the quick release handle and rotate the workpiece 180 degrees, or exactly 1/2 a turn. Reinsert the workpiece and close the quick release handle to secure it in place. Now plunge the bit back down into the workpiece and mill the second pass. When the carrier tray reaches the stop, lift the router bit out of the workpiece and turn off the linear drive motor. Place a clamp on the top rail against the carrier tray. Then move the router stop on the far side and position the router off to the side of the workpiece. Open the split nut so that the carrier tray will not move, and then slide the microswitch out of the way. Turn on the router and plunge the bit down off to the side of the workpiece. Then start the linear drive motor, and while holding the carrier tray against the clamp, bring the router bit slowly to the center of the stock, and then allow it to rotate 1 complete turn. Now move the carrier tray 1½ inches towards the headstock and repeat this operation to mill the second half of the bead. When the bead is complete, slide the carrier tray back to within a couple of inches of the microswitch stops. Then close the split nut and drive the carrier back to the stop. Then set a clamp against the carrier, open the split nut, turn off the linear drive motor, and move the microswitch stops out of the way. To mill the cove, we use a 2-inch diameter core box bit. Position the router bit directly over the center of the workpiece. Rotate the stock 90 degrees and then plunge the bit down until it sets on top of it. Now set the plunge to approximately 3/8 of an inch. Move the router off to the side of the workpiece, turn it on, and plunge the bit down. Start the linear drive motor, and while holding the carrier tray against the stop, Slowly bring the router bit over to the center of the stock and allow it to rotate one complete turn. To mill the small bead at this end, we use a 3/4 inch diameter point cutting round over bit. Make a mark 3/8 of an inch from the edge of the cove. Now center the bit over the mark and plunge the bit down until it touches the stock. Now set a clamp against the carrier and set the plunge depth for 3/8 of an inch. Position the router off to the side of the workpiece. Turn the router on, plunge the bit down, start the linear drive motor, and bring the bit to the center of the workpiece. Again, allow the workpiece to make one full rotation after the router bit has brought over the center. Change the router bit to a 1/2 inch diameter 2-flute straight cutter. Now mark the starting and stopping positions for the slotted dovetails. Now center the router bit and lock the router in place with the stops. Slide the edge of the bit up to the mark and set a clamp against the carrier tray. Then repeat this step for the second mark. Plunge the router until the bit sets on the stock, and then set the plunge depth for 3/8 of an inch. Now we'll change over to the 36th position indexing plate. Now release the indexing pin to hold the stock securely in place. Plunge the router bit down into the workpiece and then slide the carrier tray to the stop and back. Now disengage the index pin and rotate the index plate 12 positions. Now make the second cut the same as the first. Index it one more time to make the third and final pass. Now change to a 7° 3/4 inch diameter dovetail bit. Reset the plunge depth for 3/8 of an inch and then cut all 3 of the slotted dovetails. When milling with a dovetail bit, You should make a relief cut with a straight cutter first, as shown here. This way you won't load the bit. The millwork for this piece is now complete. We just clean it up a little bit here with about a 220 grit sandpaper to finish it off. The last step is to cut the stock off just above the round on the slotted dovetail and right above the bead at the top. Next, insert the second workpiece. And then rotate the stock until a flat surface is as close to level as possible. Now use a pencil to mark every 9th hole on the 36 position index plate. Now change back to the surface planing bit and then move the router stops out as far as possible. Make a mark 6 inches from the headstock end and 1 inch from the tailstock end. Set a clamp at the headstock end to keep the router from hitting the index drive center or the index hubs. Then slide the router bit up against the mark and set a clamp at the other end. Now plunge the bit down until it sets on top of the stock and set the router bit plunge depth to about 1/16 of an inch. Move the router off to the side of the workpiece and plunge the bit down to the stop. Now starting at the far left corner, bring the bit toward the center until it is cutting approximately 1/4 of an inch. Slide the carrier to the stop and back to the corner. Then turn the Y-axis positioning screw 2 turns to move the router 1/2 of an inch and slide the carrier tray to the stop and back again. Now repeat this procedure until you have approximately 1/4 of an inch left. Then with the carrier tray positioned against the stop on the right hand side, bring the router bit clear through the last section and mill from the headstock toward the tailstock for the last pass. Now move the router bit out of the way and index the stock 90 degrees. Then repeat this operation on the remaining 3 surfaces. 3 sides. Now change over to the 2-inch diameter core box bit. Now bring the router bit over the center of the stock and set the plunge depth for approximately 3/8 of an inch. Move the clamp on your left approximately 1/2 of an inch. Then slide the carrier tray up against this clamp. Set the other clamp up against the carrier tray to hold it in place. Lock back the indexing pin and then replace the 36 position index plate with the gear that we just took off. Engage these gears and lock them in place. Turn on the router and plunge down off the side of the stock. Then turn on the linear drive motor and again bring the router bit over the center of the stock. Now change back to the 3/4 inch point cutting roundover bit. Also change back to the 36 position indexing plate. To set the plunge depth, plunge the router bit down until the shoulder of the roundover rests on the corner of the stock. Then rotate the stock 90 degrees and move the carrier tray down approximately 3/8 of an inch from the edge of the cove. Now position a clamp to hold it in place. Now move the router bit off to the side of the workpiece. Turn on the router and mill across the workpiece and back. Index the stock 90 degrees and then repeat this operation on the second surface. Repeat this step 2 more times to complete the cut. We now have a square into a round transition. Next, use a measuring tape to lay out the size of the mortise. Now change over to the 1/2 inch diameter 2-flute straight cutter to mill the mortises. Plunge the bit down till it just touches the stock. Then move the router side to side until the edge of the router lines up with the mark. Then set your router stops. These router stops will control the width of the mortise. Now rotate the bit 90 degrees and slide the router down until it touches the end of the mark. Use clamps at each end to control the length of the mortise. Now set your plunge depth for approximately 1/2 of an inch. Plunge the bit down in the center of the mortise and slide the carrier tray from stop to stop. Then move the router over to one side and mill to the opposite end. Repeat this procedure, milling the mortise from the inside to the out in a circular pattern. Then plunge down to the final depth and repeat this operation again. Now rotate the stock 90 degrees and mill the second mortise. Now loosen the clamping knobs and lower the headstock end 4 complete turns. On the tailstock end, you want to raise it 3 turns. Now we'll change back to the surface planing bit. Then move the router stops out as far as possible. Slide the router bit down until it lines up with a mark 1 inch from the end of the stock, and set a clamp against the carrier tray. Now slide the bit down until it goes just over the cove, and bring the other clamp up against the router tray there. Plunge the bit down until it rests on the stock just in front of the cove, and set the plunge depth for approximately 1/16 of an inch. Move the router off to the far side of the stock and return the carrier tray to the tailstock end. Starting at the back left-hand corner, plunge down approximately 3/16 of an inch and bring the router toward the center until the bit is cutting approximately 1/4 of an inch. Now slide the carrier tray until you are no longer cutting any wood and return to the stop. Then turn the Y-axis positioning screw clockwise 1 to 2 turns, depending upon how deep your cut is, to mill the next pass. Repeat this process until you have approximately 1/4 of an inch left. Then bring the router all the way toward the front and mill the last pass from the headstock toward the tailstock. Then plunge down approximately 3/16 of an inch for the second pass, and repeat this process until you have milled the full plunge depth. Because we have set the adjustable bed to mill a taper, we will remove more material at the tailstock end than at the headstock end. Therefore, we will mill the surface in 2 or 3 passes. When using the surface planing bit, you shouldn't mill more than about 3/16 of an inch at a time. If, however, you use a 1 inch diameter 2-flute straight cutter, you can remove up to 3/8 of an inch in each pass. Move the router bit off to the side, and then rotate the workpiece 60 degrees, or 6 holes in the 36th position index plate. Then engage the indexing pin to secure the workpiece, and repeat this milling process for all 6 surfaces. For the tapered flutes, we'll use a 1/2 inch diameter core box bit. Center the router bit directly over the stock, and then lock it in place with the router stops. Raise the headstock end 1/4 of an inch or 1 complete turn and lock it in place. Bring the router up to the headstock end and plunge the bit down till it rests on the stock. Then set your plunge depth for 1/8 of an inch. Now turn on the router and plunge down the full depth. Then slide the carrier tray from the headstock to the tailstock end. Notice that we've moved the clamps in at both ends approximately 1 inch so that the flutes do not run off the end of the stock. Now index 6 positions or 60 degrees to mill the flute in the second surface. Repeat this process for all 6 surfaces. This part is now complete. All that is left is to remove the indexing hub and cut off the stock at the desired length. These 2 samples illustrate the 5 basic operations of the Woodchuck. By combining these operations and changing router bits, you can create endless variations of custom milled components. One of the new accessories available for the Woodchuck is the split nut. To install it, simply open the nut and slide it onto the linear drive screw, and secure it to the carrier tray with a cap screw. The most obvious advantage of the split nut is that it will double your production speed. When you've completed milling a spiral cut, you can simply open the nut, return the carrier tray to the starting position, re-engage the nut, and begin milling the next pass. It is made from Delrin, a high-tech bearing material that is self-lubricating and wears like brass. This allows us to cut the threads with practically zero backlash. You can open the nut at any position and rotate the workpiece without moving the carrier tray. You can also lock the nut closed with the captive screw if you desire. We used the split nut on the spiral sample piece. It allowed us to mill the bead and cove right at the end of the rope by setting a stop and opening the nut to mill around the circumference of the workpiece. Another very powerful accessory is the Y-axis template follower. These brackets attach permanently to the top rail opposite the linear drive screw. You then build a baseboard that can quickly be mounted at any time to support a template. You also replace the universal router base with the base shown here. Once you attach this base to the router, you can use it all of the time. It has a roller that follows the template. This roller can easily be removed when you're not using the template follower. You then build a template and attach it to the base board. Then slide the carrier tray from the headstock to the tailstock. The router will follow the template as you cut on the side of the workpiece. You can plunge down approximately 1/2 an inch at a time to mill the stock depending upon the wood. Or to speed up the process, you can cut the profile on a bandsaw first and make a cleanup pass on the system. The template follower will ensure that every piece comes out identical. Because you are not turning the stock as you do in a lathe, you don't have to mill it round. You can index to mill on any surface that you desire. You can use 2 or more templates to create cabriolet legs, or spiral the profile to create flame finials. The possibilities are virtually endless. You can also combine the template follower with the indexing and XY milling capabilities to add decorative cuts or precision joinery. The parts don't have to be symmetrical at all. Just use your imagination and create any style that you can think of. Here are just a couple of samples that you can reproduce over and over again. The Y-axis template follower adds an entirely new dimension to your work. The dust collection system attaches to your existing carrier tray and has a brush system that allows you to place it through the workpiece. You can then attach a shop vac or commercial dust collector to the carrier. This system will effectively remove the chips and sawdust even when milling the workpiece to a round. It allows you to mill up to approximately 5-inch diameter stock, or can be removed when working with larger diameters. Shown here is the center stock stabilizer. It quickly mounts on top of the bed rails between the headstock and the tailstock, and it can be secured in place with a plate from the bottom if necessary. This system uses a scissor jack mechanism to automatically adjust the 4-inch rollers for different size stock. The wide rollers then support the round stock when milling spirals. It can be adjusted to support tapered or even turned components and will stabilize the system to minimize the chatter. Optional accessories for the spindle shaft and the headstock include the 12 and 8-position index drive centers. Also available are the 3 and 4-jaw chucks. The 4-jaw chuck allows you to mount square stock without using the index hubs. You can also close it down to hold small diameter stock that you wouldn't be able to mount the index hubs on. When used with the center stock stabilizer, this makes a quick and easy way to add accent cuts to turned components. Also available is the complete setup for milling wooden pen and pencil sets. Shown here is the double mandrel used to mill both halves of the pen at the same time. Simply drill the blanks, glue in the tubes, slide the blanks onto the mandrel, and then secure them in place with a nut. Then set the tailstock to support the end of the mandrel and use a surface planing bit to mill the blank to a round. The router mills a very smooth finish that requires very little sanding to finish. Plus it's very quick and easy. Just rotate the stock and slowly slide the carrier tray from end to end. Now you don't have to be an expert turner to make pins out of materials including wood, plastic, corian, or mineral talc. Shown here is the optional spindle drive motor. By disengaging the gear reduction set, you can rotate the spindle shaft in both directions independent of the linear drive screw. To control the spindle drive motor, point the toggle switch on the junction box towards the headstock. You can then set the direction and the speed of the spindle drive motor. Pointing the toggle switch toward the tailstock returns control to the linear drive motor, which now controls the position and movement of the carrier tray, but does not rotate the spindle shaft. This accessory has several uses. It will also speed up your production work by eliminating the need to set clamps or move the micro switches when milling beads and coves as shown on this sample piece. Another exciting accessory for your router is the eliminator chuck. It uses a differential screw to open and close a set of smooth jaws to hold your router bit snugly in place, but release it instantly. Currently it is only available for the Porter cable routers, and as shown throughout this video, it is extremely fast and easy to use.